Okay, we are ready to start. Just the usual confirmation. If you can see the shared screen.
Yes, sir.
Thank you. Thank you. Okay, um, so we are on chapter 7, which is about the properties of expectations. And we know the expectation um, of a random variable. Expectations. This is what we did last time. So the definition of expectation for a random variable x is summation or integral, depending upon whether it's discrete or continuous, summation upon all values of x or integral over all values of x, x multiplied by the probability density function or probability mass function as you see fit, whether it's discrete or continuous. So this is how we define the expected value. And last time what we also did is we said that expectation is linear. What that means is the expected value of ax plus by, where x and y are random variables, a and b are constants, is going to be a times expected value of x plus b times expected value of y. Okay. I could also stick in a constant c here, so that would be c just like that. All right. So this is what we proved last time, and then expected value of x multiplied by y. We said that this is also equal to expected value of x multiplied by expected value of y only if x and y are independent. Only if x and y are independent. So the linearity holds irrespective whether x and y are independent or not. They may be dependent, the linearity of expectation will still hold. Okay, but if you want the product of x and y, the expected value of that to be equal to the expected value of x multiplied by expected value of y, then they have to be independent. And this is also what we proved last time. Another thing that we defined last time was sample mean. Sample mean. And what was sample mean? There is a large population, और उसमें से एक छोटा सैंपल ले लें. Take a small sample, random sample. और इस सैंपल के अंदर भी 100, 50, 200 कितने लोग होंगे, या size of the sample mean. So sample of size n. हमने इसमें क्या कहा था? हमने कहा था कि each constituent of the sample, जो सैंपल हमने उठाया है जिसके अंदर 100 लोग हैं या 200 लोग हैं, जितने भी लोग हैं, each one of those is a random variable, x1, x2, all the way up to xn, okay, are independent if the population is very large, infinite, are independent and identically distributed. जिसको हम इन शॉर्ट कहते हैं IID, x1 and x2. So इसका मतलब है एक्सपेक्टेड वैल्यू उनकी सेम होती है, उनकी वेरिएंस सेम होती है, एंड एक्सपेक्टेड वैल्यू ऑफ x1 xi for every value of I was mu, and variance of xi is sigma square. So ये जो हमने सैंपल इसमें से पिक किया है, ईच इंडिविजुअल इन दिस सैंपल और ईच पॉइंट इन दिस सैंपल, ये सैंपल जो होगा उसके अंदर देयर विल बी मोर देन सम पॉइंट्स, सिंगल पॉइंट का सैंपल नहीं होगा. वेल, You can have a single point sample as well, but this could be a large sample of n points, but much smaller than the entire population. Each guy that you pick up will have a mean of mu and variance of sigma square, and mu and is the mean of population. वो पूरी population का mean होगा, वो उसकी heights हैं या weight हैं या age है, whatever, any property, and sigma square is the variance of the mean, variance of the population. तो हमने sample mean define किया था. We defined sample mean as x bar. वैसे तो हमें पता है कि the mean is a constant, but sample mean is a very special kind of a mean, and this is equal to 1 over n summation I is equal to 1 to n xi. So sum of all the xi's divided by n. We know that each of these xi's is a random variable. So we will notice that x bar is a function of many random variables, or in precisely n random variables. So x bar itself is a random variable. ये खुद से भी एक random variable होगा. And the reason that it is a random variable is because the sample that I have picked from here, ये जो छोटा मैंने sample pick किया है, this sample is randomly chosen from the entire population. Since the value of x bar depends upon, वो उन सबका mean लिया हुआ है, लेकिन the value of x bar is dependent upon what that random sample is going to be. तो इसलिए x bar is going to be a random variable itself. So last time हमने ये भी show किया था कि expected value of x bar was equal to mu. Expected value of x bar was also equal to mu. Yeah. And then we had a couple of examples जिसमें binomial और negative binomial की हमने expected value find out की थी. And then another couple of problems, hat matching वाली problem हमने solve की थी. And then coupon collection problem. These are the problems that we had seen in an earlier chapter. But if we are only interested in the mean value, expected value of some quantities from the expected number of matches of hat matches, or the expected number of coupons that you need before you get a complete set. If we are only interested in the expected value, it seems that it becomes a lot easier to do the computation by using the properties of expectation. And we did that last time. Now, today, what we are going to talk about is, we are going to talk about quantifying the dependence between random variables. If the random variables are dependent, so what that qualitatively means कि एक random variable बढ़ रहा है तो दूसरा random variable भी बढ़ेगा. If the winter comes, the fog will increase. If the winter comes, then the air quality will decrease. Okay? So, this is a qualitative statement. It does not tell you okay, what is the exact relationship between the temperature and the pollution, and the pollution or the fog level or the air quality index. Okay? What is the relationship between those random variables? So I'm going to quantify that. Quantifying the dependence between random variables. Okay. So far what we have done is, we have said that the random variables, they are either independent or they are dependent. But I have not told you how dependent they are. Are they fully dependent? Are they half dependent? Are they 72% dependent? So अभी तक हमें सिर्फ ये पता है कि ये dependent हैं या independent. Okay. But if we want to quantify the dependence, then we need to define certain things. Okay. So we know that if x and y are independent, then the dependence is zero. The dependence between them is zero. Then we can write fxy is equal to the product of the two density functions, marginal density functions. Okay. X वाला और y वाला जो है separate हो जाते हैं in the join. Okay. This was the property that we had studied earlier. Okay. Also, if x and y are independent, then expected value of h of x, some function of x, into g of y, some function of y, we can prove that. It's a one line proof. और ये उसी तरह से है जैसे हमने expected value of x and y उसको हमने prove किया था expected value of x multiplied by expected value of y. बिल्कुल उसी तरह से we can show that this would be equal to expected value of h of x, expected value of g of y, if independent. Okay. But what if x and y are dependent? If they are dependent, then knowing one random variable will tell you something about the other. ठीक है? Independence का मतलब यही है कि if x and y are independent, knowing one does not tell you anything about the other. लेकिन if you look at the modern techniques of everyone has been hearing about machine learning होती है. Machine learning में क्या? You need to predict something. Based on the past history. So, for example, if you look at a grocery store, and if you want to predict what the sales would be tomorrow, okay, blindly you won't be able to answer that. But if I give you the data of past week, then you may be able to answer that. If I give you the data for past month, your answer might be even better. If I give you the data for the entire year, then you might have a really good answer, a predictive answer for the sales that I should expect tomorrow. Okay. So if I give you the information about the weather of Lahore for the past 10 years every single day, so you may be able to predict with some precision that how the weather is going to be like tomorrow. वो किस तरह का weather होगा. And this is not based upon any kind of atmospheric measurements. Atmospheric measurements से तो सारे लोग करते ही हैं. But instead of using the atmospheric measurement, I may be able to use the historical data to predict the future data. So in that case, basically what you are looking at is you are looking at past random variables, and you are trying to guess the value of a future random variable. If the weather every day is independent of each other, then knowing the weather for the past million years will also not tell you anything about the weather tomorrow, agar wo independent hota hai. But if there is a dependence, then knowing one will tell you something about the other. So if x and y are dependent, so this is just to motivate why are we studying this. If x and y are dependent, then knowing one might tell you something about the other. Which is nice. Okay. And how do I measure that? So recall करें कि एक single random variable के बारे में मुझे information कैसे मिलती है. By knowing its mean, by knowing its variance, I get some information about the random variable. I don't get full information about the random variable. Mean और variance अगर मैं आपको बता दूं कि ये एक random variable की distribution ना बताऊं, तो you cannot tell too much things about the random variable. Okay, you can tell everything about the random variable only if I tell you the full distribution. अगर मैं आपको उसका PDF बता दूं या PMF बताऊं, only then you can tell everything about the random variable. But if I only give you the mean or only give you the variance, or I give you both mean and variance, then you can tell something about the random variable, but not too much about the random variable. Okay, but that's for a single random variable. What about two random variables? How do we define the dependence between two random variables? उसके लिए एक quantity define करते हैं. This is called covariance. This tells you the relationship between two random variables, and the covariance between x and y, two random variables x and y, is very similar to the variance. Remember कि variance का formula क्या था? Variance of x, if anyone recalls, this was x minus expected value of x whole square. ये था. Okay. So you can think of it as x minus expected value of x multiplied by x minus expected value of x, और उसकी product की आपने expected value ले ली है. On the similar lines, covariance between x and y is defined as the expected value of x minus ex into y minus ey. Y minus ey, and you can solve it a little bit. So this will become expected value of xy multiply किया minus y expected value of x minus x expected value of y plus expected value of x expected value of y. Okay. And since expectation is linear, product of two random variables is another random variable. And this a random variable multiplied with a constant is another random variable, and this some constant. So linearity of expectation को यहाँ पे लगाएंगे. So you will end up getting expected value of xy minus. So see, this guy expected value of x is constant. So expected value of y into ex will simply be expected value of y, expected value of x, minus अगला वाला expected value of x, expected value of y, plus expected value of a constant. Expected value of a constant is that constant itself, which would be expected value of x, expected value of y. Okay. Right. So this will turn out to be, ये इनमें से कुछ टर्म्स कैंसिल हो रही हैं, ये टर्म्स हमारी कैंसिल हो जाएंगी. This guy will go with this guy. So I will end up getting expected value of xy minus expected value of x, expected value of y. This is called the covariance between x and y. Covariance between x and y. Okay. So now my question is, what if x and y are independent? अगर वो independent हैं तो क्या होगा? What would be covariance? Answers in the chat window. Answers in the chat window. 0. So why? If x and y are independent, then expected value of xy is equal to the expected value of x multiplied by expected value of y. Okay. Which implies that covariance between x and y would be equal to 0. If x and y are independent. Okay. So what does covariance tell you? Covariance tell you that if x is high, then y is high. If x is low, then y is low. That is what covariance tells you. It tells you the relationship between the two random variables. So ऐसा करते हैं कि let's do an experiment. Let's do an experiment and we get these points. We get these points और ये मेरे पास x के points इधर आ जाते हैं y के vertical axis पे. So let's say कि you get these points, tuck, 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 tuck. You know, these points here. Does not tell me anything about x and y का relationship. मुझे कुछ पता नहीं चल रहा. इसमें कुछ पता नहीं चल रहा. But let me draw another figure. Okay. And you might be able to say something about x and y. Something about x and y. Okay. So now I draw these points कि experiment किया, एक बार ये आया. ठीक है. सो x की ये वैल्यू निकली और y की ये वैल्यू, दोबारा किया ये वैल्यू निकली, फिर किया फिर ये वैल्यू निकली, फिर ये फिर ये फिर ये फिर ये फिर ये फिर ये, you know, these kind of values. Now if you notice in this figure, so these values are randomly generated. हर जो मैंने ये red dot इसमें मैंने point out किया हुआ है, every single red dot is a randomly generated data point, randomly generated from x and y. x की एक दफा एक्सपेरिमेंट किया x की वैल्यू मिल जाएगी, एक्सपेरिमेंट किया y की वैल्यू मिल जाएगी. सो x और y की जो भी वैल्यू मिली, इनफैक्ट फ्रॉम अ सिंगल एक्सपेरिमेंट यू गेट द वैल्यू ऑफ x एंड द वैल्यू ऑफ y. उसको बस प्लॉट करना है हमने यहाँ पे. सो बाय लुकिंग एट दिस यू कैन से दैट इफ x हैज ए हाई वैल्यू द लाइक्लीहुड इज y will have a high value. देखिए इधर का यहाँ पे कोई पॉइंट नहीं है, इस जगह पे कोई पॉइंट नहीं है. ऐसे नहीं हो सकता कि y जो है आपके पास बहुत बहुत हाई हो और x जो है वो बहुत लो हो, ऐसा हो नहीं रहा. सो दिस फिगर इज टेलिंग मी कि ये जो मेरी डिस्ट्रीब्यूशन है उसके अंदर से जब मैंने ये सैंपल्स पिक किए, इसमें इसको मैंने एक्सपेरिमेंट रन करके ये बहुत सारे पॉइंट्स प्लॉट किए हैं, ये सारे पॉइंट्स ये इस तरह से आ गए, यू नो. सो दिस टेल्स मी if x is high then y is high, if x is low then y is low. Okay, if x and y increase together then we say that covariance between x and y is greater than 0. Okay, if they decrease together as they are doing there here now, if they decrease together then also we say that the covariance between x and y is greater than 0. So what would be the case of a covariance of x and y less than 0? उसकी भी आपको पिक्चर बना के दिखा देते हैं. If x is here and y is here, you perform the random experiment, and in the random experiment you start getting points like this. ये आपको points कुछ मिल रहे हैं इस तरह, ये random points मिल रहे हैं. एक दफा एक्सपेरिमेंट किया तो आपको एक पॉइंट मिलेगा, वो x और y की वैल्यूज होंगी. सो अगर इफ यू गेट दिस काइंड ऑफ अ डिस्ट्रीब्यूशन, दिस इज जस्ट एक्सपेरिमेंट रिपीटेड, यू नो, 50 टाइम्स. ये जितने भी डॉट्स मैंने लगाए 30-40 दफा ये एक्सपेरिमेंट को रिपीट किया, उसको प्लॉट कर दिया x और y की जो भी वैल्यूज मेरे पास आई थी. सो इन दिस केस कोवेरियंस इज less than 0. Covariance between x and y is less than 0. Is less than 0. Okay. So कोई एग्जांपल करते हैं. By the way, if x and y are independent, their covariance is going to be 0. If they are independent, just like this, इस केस के अंदर, then covariance is going to be 0. Covariance between x and y would be equal to 0. And this will also be the case when x and y are independent. By the way, if the covariance is 0, that does not necessarily mean that they are independent. That does not necessarily mean that they are independent. And there is an example which shows exactly that. कि x और y dependent है, लेकिन covariance दोनों की 0 निकल आती है, just because expected value of x, y, expected value of x, expected value of y. ये formula के तहत जो है ना, according to this formula, the covariance turns out to be 0, but x and y are not independent. ये एक दो examples हमने notes के अंदर की हुई हैं. Please make sure you take a look at those. Okay. So some covariance relationships here. Covariance relationships. So let me just repeat again. Covariance between x and y is simply the expected value of x में से उसका mean minus कर दें, multiplied by y में से उसका mean minus कर दें. ठीक है. Covariance of, and by the way this we found out this to be equal to expected, ये हमने पहले simplify किया, x and expected value of y. Then the covariance between x and x, So how many people think that x and x, they are dependent? X and x, they are dependent. Yes or no? Yes or no? Of course, yes. X is dependent upon x. वो ये तो perfect maximum, इससे ज़्यादा covariance नहीं हो सकती. Maximum covariance यही हो सकती है between two random variables which are exactly the same. In fact, it's the same random variable, x is random variable. So according to this definition, this would be equal to expected value of x square minus expected value of x whole square. Okay, and we recognize this. What is this guy? Answer in the chat window. What is this guy? This is variance of x. Great. Now, by definition of the covariance between y and x is the same as the covariance between x and y. दो चीजें multiply हो रही हैं, doesn't matter first multiplied with the second or second multiplied with the first. Okay. Now, there is another thing that I want to mention is covariance between ax and by would be equal to a और b ये कांस्टेंट्स हैं. ये इस इक्वेशन के अंदर अगर पुट करें तो a और b जो कांस्टेंट्स हैं वो बाहर निकल आएंगे, क्योंकि a टाइम्स x का मीन जो है वो भी a टाइम्स एक्सपेक्टेड वैल्यू ऑफ x होगा. सो दिस विल सिंपली बी इक्वल टू ab टाइम्स कोवेरियंस ऑफ xy. Covariance of xy. Okay. We can extend this to many multiple random variables as covariance of summation of I is equal to 1 to n ai xi comma summation j is equal to I भी कर सकते हैं, does not matter, j is equal to 1 to m bj yj. The covariance between this sum and this sum, ये भी एक random variable है और ये भी एक random variable है, and this first random variable is the sum of many random variables. The second random variable is also the sum of many random variables. This is equal to I is equal to 1 to n and j is equal to, यहाँ पे हमें j ही करना पड़ता, j is equal to 1 to m ai bj covariance of xi xj. सिंपली इसकी जो है ना ये एक्सटेंशन है. Now let me find out the variance of sums. Now this topic is going to be extremely useful in finding the variance of many random variables that we have studied before, जिनकी variance निकालना इतना आसान नहीं था, जरा मुश्किल सा था. Okay, हम वो भी बड़ी आसानी से निकाल सकते हैं. कैसे? By using the variance of the sum formula. And what is the variance of the sum? The variance of the sum, variance of summation I is equal to 1 to n xi would be equal to, by definition of the covariance, ये हमने देखें कहा था कि variance of x is equal to the covariance between x and x. So this really should be equal to covariance between this guy with itself, this guy with itself. So I is equal to 1 to n xi, and then दूसरे में भी I यूज कर सकते हैं, लेकिन I will use j just to avoid any confusion. ठीक है, क्योंकि ये समेशन का वेरिएबल है, वो I भी हो सकता है, कोई इशू नहीं है उसमें, लेकिन जब उनको हम इकट्ठा करके लिखेंगे तो फिर I और j को अलग-अलग ही लिखना पड़ेगा. So this would be equal to, now if I apply this formula here, ये जो variance of, ये covariance of sums मैंने लिखी हुई थी, इसको देखें कि a's जो हैं वो सारे के सारे 1 हो गए हैं, b's जो हैं वो भी सारे के सारे 1 हो गए हैं, और ये yj की जगह पे भी सारे x जाएंगे. So बड़ा इजी है यहाँ पे ये फॉर्मूला लगाना. By the way, this should be yj होना चाहिए. ठीक है, so easy to apply the formula here. That would be I is equal to 1 to n, j is equal to 1 to n, वो भी n तक ही जा रहा है. ठीक है, कोवेरियंस बिटवीन xi and y नहीं है, y की जगह पे भी हमने xi लिखा हुआ है, तो it would be xj, covariance between. So now you see कि I am taking I from 1 to n and j from 1 to n. So total कितनी terms हैं यहाँ पे? Total कितनी terms? Answers in the chat window. Total terms कितनी है? So j is going from 1 to n and I is also going from 1 to n. How many terms in this summation? So एक अंदर वाला लूप है वो 10 दफा रन कर रहा है, बाहर वाला लूप भी 10 दफा रन कर रहा है. So that would be, so think about it, for each value of I from 1 to n, I have j running from 1 to n. So I की 1 के लिए भी j 1 से n तक जाएगा, I की 2 के लिए भी 1 से n तक जाएगा, and so on and so forth. So I will have n square terms here. ठीक है, उसमें से मैं वो वाली टर्म्स जो है वो अलग कर लेता हूं जिसमें i और j दे आर इक्वल, i और j दे आर इक्वल, उनको मैं अलग करता हूं. ठीक है, सो दिस वुड टर्न आउट टू बी समेशन. कितनी ऐसी टर्म होंगी जिसमें i और j इक्वल हो जाएंगे? कितनी ऐसी टर्म्स होंगी जिसमें i और j इक्वल होंगे? हाउ मेनी टर्म्स इन विच i एंड j विल बी इक्वल? हाउ मेनी टर्म्स? आंसर्स इन द चैट विंडो. i भी 1 से 100 तक जा रहा है, j भी 1 से 100 तक जा रहा है. ठीक है, हाउ मेनी टर्म्स इन विच i एंड j आर इक्वल? ऑफ कोर्स दे वुड बी n. सो ये आपके पास होगा k इज इक्वल टू 1 to n कोवेरियंस ऑफ xk with xk. ये दोनों i और j जो है मिलके ये k के बराबर हो गए एंड k goes from 1 to n प्लस summation your i is equal to 1 to n and j is equal to 1 to n but i not equal to j, क्योंकि i equal to j वाली चीजें मैंने इधर लिख दी हैं. ठीक है, so covariance of xi xj. Okay, and this would be equal to summation of k is equal to 1 to n. This is variance of xk. This is variance of xk. ये तो हमें पता है कि covariance of x and x जो है वो variance of x होती है. So plus this same guy here. Okay. If xi xj are pairwise independent for all i and j, तो ये जो कोवेरियंस i और j जहां पे i j के इक्वल नहीं है वो वाली टर्म आपके पास सारी जीरो हो जाएंगी बिकॉज दे आर इंडिपेंडेंट. अगर इंडिपेंडेंट है तो कोवेरियंस आपके पास जीरो होनी चाहिए. ये भी हमने ऊपर बताया कि इफ दे आर इंडिपेंडेंट, इफ x एंड y आर इंडिपेंडेंट, द कोवेरियंस बिटवीन देम इज जीरो. ओके, सो दैट मींस कि इफ xi and xj, i is definitely not equal to j in this summation. If they are not equal and they are independent, then their covariance has to be equal to zero. तो ये सब जीरो हो जाएगा. So आपके पास आंसर क्या आ जाएगा? Variance of summation I is equal to 1 to n xi, which was this left hand side here, is equal to the summation of, ये k है, k की जगह मैं इसको i से ही लिख देता हूँ, i से सम कर देते हैं, i is equal to 1 to n variance of xi. So variance of the sum is equal to the sum of the variances, if independent, only if independent, independent या correlated. So very interesting. So I will come back to the topic of sample mean. ये जो हमने आज कवर किया, last time cover किया, sample mean. So let's say you have these observations x1, x2, ... up to xn are IID from a population, ठीक है, and everyone xi has a mean of, expected value of xi is mu and variance of xi is sigma square. This is population mean, and this is population variance. ये पूरी population की variance है. I had defined x bar as the sample mean to be equal to 1 over n summation I is equal to 1 over to n xi. This is the definition of sample mean. This was the definition of sample mean. Okay. And we had already found out that expected value of x bar was equal to mu. Already found. ठीक है, हमें पता है कि x bar जो है is a random variable. So if it is a random variable, I found its mean. Maybe it's a natural question to ask, what is variance of x bar? Variance of x bar क्या है? Okay. What would be the variance of x bar? So let's try to find that out. Okay. So variance of x bar is going to be equal to the variance of 1 over n summation I is equal to 1 to n xi. Okay. Now if you recall कि variance of a times x ये क्या होती थी? This was a square variance of x. This was a squared variance of x. Okay? So this will turn out to be 1 over n square variance of summation I is equal to 1 to n xi. Okay? Now, ये भी हमने ऊपर प्रूव किया कि the variance of sum is equal to the sum of variances if they are pairwise independent, which they are. ये सारे xi's जो हैं ये IID हैं, independent and identically distributed. So xi's are IID, independent and identically distributed. So this would be equal to variance of sum जो है वो sum of the variance के बराबर हो जाएगा. I is equal to 1 to n variance of xi, okay, which is equal to 1 over n square. I is equal to 1 to n. What is variance of xi? Variance of xi we already know is sigma squared. Is sigma squared. Sigma squared. So this would be equal to 1 over n square into n times sigma squared, which is equal to sigma squared over n. Okay. So x bar. So x bar has an expected value which is equal to mu, and the variance of x bar is equal to sigma square over n. Don't forget that mu was the mean of the population and sigma square was the variance of the population. इसका मतलब क्या हुआ? इसका मतलब ये है कि जब मैं एक सैंपल लेता हूं, when I take a sample from the population, वो जो सैंपल आया रैंडम सैंपल है, उस सैंपल की एक्सपेक्टेड वैल्यू जो है, उस सैंपल के मीन की एक्सपेक्टेड वैल्यू will be equal to the population mean. इसका मतलब है कि if I take one sample and पाकिस्तान की पॉपुलेशन में से यू पिक 1000 रैंडम पीपल, वो जो 1000 लोग आपने पिक किए हैं उनकी हाइट का जो मीन आएगा, इट विल नॉट बी इक्वल टू द मीन ऑफ द एंटायर पॉपुलेशन ऑफ पाकिस्तान, बट वो जो मेरे पास 1000 लोगों की हाइट का जो मीन आएगा, इट वुड बी अ रैंडम वेरिएबल बिकॉज दोस 1000 पीपल हैव बीन पिक्ड रैंडमली. ओके, सो उसकी जो एक्सपेक्टेड वैल्यू होगी, सिंस दैट वुड बी ए रैंडम वेरिएबल, द सैंपल मीन वुड बी अ रैंडम वेरिएबल, तो उसकी एक्सपेक्टेड वैल्यू जो है वो पॉपुलेशन मीन के बराबर होगी. बट द वेरिएंस ऑफ एक्स बार, द वेरिएंस ऑफ एक्स बार वुड बी इक्वल टू द पॉपुलेशन वेरिएंस डिवाइडेड बाय n. व्हाट दैट मींस इज increase n means variance of x bar decreases. And what does that mean? एक random variable की variance क्या बताती है? What does the variance of a random variable tell you? The variance of a random variable tells you your tendency to steer away from the mean. Okay, if the variance is very, very small, most of the values will be close to the mean. If the variance is large, then most of the values will be away from the mean. Uniform distribution has a large variance, and a distribution which looks like this, ये ऐसी आपके पास distribution है. This has a small variance. Compared to this guy. This guy has a large variance. Okay, so what we are saying here is that variance of x bar is sigma square over n. Okay? If you increase n, you decrease the variance of x bar. What that means is that the tendency of the x bar, because x bar is a random variable, the tendency of x bar to move away from the mean will be very low. जैसे मैं n को बढ़ाऊंगा तो वैसे वैसे मेरी tendency to move away from the mean will be low, which means कि अगर मैं n को बहुत ज्यादा बड़ा कर दूं, if I increase n to be very, very high so that the variance of x bar is extremely small, that means कि x bar की मैं कोई भी वैल्यू जो है वो निकाल लूं, कोई भी सैंपल वैल्यू निकाल लूं, that would be equal to its mean value. Which will be mu, which means कि वो मेरी population के जो mean है वो मुझे दे देगी. What that means in quantitative terms कि अगर मैं 10 लोग पाकिस्तान की population से collect करता हूँ और 10 लोगों की height का sample निकालता हूँ, तो जो एक average value आएगी, although कि that would be a rough representation of the average height of the Pakistani population, but if I increase that number from 10 to 10,000, then the Parisian in my mean is going to be high. If I increase it from 10,000 to 1 million or 10 million, it would be even higher. उसको 220 million तक लेके चले जाएं, यानी infinite population हो गई, which is the total population of Pakistan, then you get the exact answer. Then you get the exact answer. For infinite n, you get the exact answer. Okay, so that's an interesting idea about this. Now, अगर कोई चीज sample mean होती है, तो is there something like sample variance? I wouldn't have asked that question if there was not. Okay, so there is something called sample variance as well. Is there something as sample variance? And sample variance is defined as s square is equal to 1 over n minus 1 summation I is equal to 1 to n xi minus the sample mean x bar whole square. देखें वेरिएंस हम कैसे कैलकुलेट करते थे? if you recall करें कि वेरिएंस ऑफ a random variable was calculated as 1 over n summation I is equal to 1 to n, okay, xi minus x whole square, xi minus x whole square. Sorry, this should be xi minus expected value of x whole square. यानी रैंडम वेरिएबल जो वैल्यूज लेता है उसमें से मीन को माइनस करते जाएं, स्क्वायर लेते जाएं और फिर सम कर दें, आखिर में n से डिवाइड कर दें. दिस इज हाउ यू कुड कंप्यूट द वेरिएंस मैनुअली. उसको मैनुअली कैलकुलेट कर सकते थे. डिस्क्रीट के केस में तो ऐसे ही कर सकते थे. ठीक है. नाउ आई डिफाइन दिस गाय एस स्क्वायर व्हिच इज नॉट क्वाइट द सेम एज दिस गाय बट मिलता जुलता है कुछ से, सिमिलर है. ठीक है. वी कैन शो दैट not going to prove here, but the proof is in the class notes that expected value of s square is equal to the sigma square. So s square जिसको हम sample variance कह रहे हैं, this is a sample variance. The expected value of that sample variance s square is also a random variable. Why it is a random variable? Because s square contains these random variables in here. ये random variables इसके अंदर है, ये some function of many random variables है, so it would itself be a random variable, and the expected value of s square would be equal to sigma square. Okay. Now I'm going to use these properties that we have just learned in order to define or in order to calculate the variances of some random variables that we have already calculated. Variance of binomial NP. ये कैसे कैलकुलेट करनी है? पहले ये एक लंबा सा प्रोसेस था, हमने कैलकुलेट किया था बाइनोमियल एनपी की वेरिएंस, जिसमें हमने मोमेंट कैलकुलेट किया, फिर हमने y पावर n की एक्सपेक्टेड वैल्यू को रिकर्सिवली डिफाइन कर दिया, वहां से हमारे पास वेरिएंस आई थी इन चैप्टर 4. Okay, now I will show you a method using which you can quickly calculate the variance of the binomial just like that. Okay, recall that x is binomial NP when it is equal to x1 plus x2 plus so on up to xn, and x is binomial with parameters n and p when each of these xi is Bernoulli random variable with parameter p. ठीक है, तो उन सबको सम अप कर दें तो ये आपके पास बाइनोमियल आ जाता है. ठीक है, and all of these Bernoulli random variables are IID. They are independent of each other. Each trial is independent. हर ट्रायल के अंदर जो सक्सेस आ रही है वो is independent of the success in any other trial, and Bernoulli p is the random variable which governs one trial, success in one trial. Okay, now जो हमने ऊपर अभी बताया कि variance of x would be equal to the variance of summation of I is equal to 1 to n xi, which is each of those is Bernoulli. Since these are IID, I can write this variance of sum as the sum of variances. I is equal to 1 to n variance of xi. Okay. And since xi's are IID, इन सब की variance भी एक जैसी होगी, इन सब की variance भी एक जैसी होगी. So this would really be equal to n times variance of xi. The variance of the binomial is equal to n times the variance of Bernoulli. Okay. And what is the variance of Bernoulli? Recall कि xi जो है वो हमने define किया था 1, xi was 1 if ith trial is a success. If the ith trial is a success and 0 otherwise. Okay. And expected value of xi was equal to, this was with probability p, with probability p. So this was equal to simply p. Okay. And expected value of xi squared, what was this? This was also p. This was also p. Okay. So the variance of xi was equal to expected value of xi square minus expected value of xi whole square, which is p into 1 minus p. Okay. Very easily calculated. Then I can calculate the variance of the binomial random variable with parameters n and p as n times the variance of the Bernoulli, which is p into 1 minus p. देखें कितनी easily calculate होगा, कितनी easily calculate होगा. Okay. So there is another example in the notes that I'm going to skip on that. Please make sure you take a look at these class notes, जो sample notes के folder में पड़े होते हैं in the LMS के resource section पे. So that is about the sample mean and precision. I am going to talk about another parameter which is called correlation, which is very similar to covariance, but it's a normalized covariance. It's a normalized covariance. जरूरत क्यों पड़ गई covariance को normalize करने की? इसलिए जरूरत पड़ गई कि because if you look at the covariance between two random variables x and y, that was defined as expected value of x minus expected value of x. So let me just call it mu x. Expected value of x is just mu of x. Multiplied by y minus mu y, which is the expected value of y. So this was the definition. This was the definition of covariance. And we already saw that if I try to calculate the covariance between 10x and y, now if you think about it, y is the same random variable here, and this x guy and 10x guy, there is really, except for this factor of 10, अगर मुझे x पता हो तो मुझे 10x भी पता है. There is no new information in here. There is no new information in here. If I know x, I completely know 10x. ठीक है? अगर x पता है तो 10x का भी पता है. ठीक है? So if this is the covariance between x and y, what would be the covariance between 10x and y? The covariance between 10x and y, we had seen that this is 10 times covariance of x and y. ठीक है? लेकिन ये, this is not normalized. Why? Because the information contained in x is the same as the information contained in 10x. The information contained in this y is the same as the information contained in this y. So I should be getting the same answer. यहाँ ये क्या वजह है? ऊपर तो मुझे covariance of x y मिल रहा है, नीचे 10 times covariance of x y मिल रहा है. So I should try to normalize this. उसको normalize करते हैं. Normalize करने के लिए let me recall something. ठीक है? उसको normalize करते हैं. Normalize the covariance by noting कि variance of x over sigma x, where sigma is the variance of x is sigma square. ठीक है? So variance of x over sigma x. Recall हमने जब वो normal random variable किया था उसकी standardization करते थे, हमने normal 0 1 बनाना था, तो हम कहते थे mean minus कर दें और variance से divide कर दें, standard deviation से divide कर दें. ठीक है? So the variance of x over sigma square x is, again recall, कि variance of a times x is equal to a square times variance of x. So this really would be equal to 1 over sigma x square into variance of x, which is also sigma x square, which is 1. So ये realize करना है हमने कि variance of x over sigma x जो है वो हमेशा 1 होती है. Similarly, variance of y divided by sigma y would also be equal to 1. इसका क्या मतलब है? इसका मतलब है कि if you take a random variable and you divide it by its standard deviation, the variance of the resultant would always be equal to 1. ठीक है? और this is not something new. This is something that we have seen when we were talking about the नॉर्मल डिस्ट्रीब्यूशन की स्टैंडर्डाइजेशन, जिसमें हम z जो था नॉर्मल 0 1, जब वो हमने बनाना होता था हम कहते थे मीन को माइनस करें और स्टैंडर्ड डेविएशन से डिवाइड करें, ऐसे ही होता था, राइट? सो नाउ आई एम गोइंग टू डिफाइन द कोरिलेशन, एंड यू विल सी कि कोरिलेशन जो है ये बड़ी इंटरेस्टिंग चीज है. अनलाइक कोवेरियंस, जो ये 10 का फैक्टर आया तो ये भी 10 के फैक्टर के साथ चली गई. सो कोवेरियंस के केस में ऐसा हो जाएगा, कोरिलेशन में ऐसा नहीं होगा. आई डिफाइन द कोरिलेशन, रो, ये सिंबल रो से डिनोट करते हैं इसको, between x and y is the covariance between x divided by standard deviation of x, y divided by standard deviation of y. Okay, so the correlation between x and y is defined as the covariance of these normalized random variables x divided by sigma x and y divided by sigma y divided by sigma y. Okay? And this will turn out to be equal to, रिमेंबर हमने कहा था कि कोवेरियंस ऑफ, रिकॉल करते हैं फिर से और रिकॉल करते हैं, कोवेरियंस ऑफ ax and by was equal to ab times covariance of x and y. ठीक है, ये भी डेफिनेशन से ऑटोमेटिकली आ जाता है. सो दिस वुड बी इक्वल टू 1 ओवर सिग्मा x सिग्मा y बाहर आ गए इनटू कोवेरियंस ऑफ x and y. This is how you define the correlation. Okay, in other words, correlation between x and y is equal to covariance between x and y divided by square root of, ये sigma x is the variance का square root, variance of x and variance of y, variance of x and variance of y. Now I try to find out the correlation between 10x and y. 10x and y. This would be equal to the covariance between 10x divided by its standard deviation. 10x divided by its standard deviation, and the standard deviation would be equal to square root of variance of 10x, comma, y divided by square root of variance of y. ठीक है, हमने कोरिलेशन कैसे डिफाइन किया था? कोरिलेशन हमने ऐसे डिफाइन किया था कि इट्स द कोवेरियंस बिटवीन दीज टू गाइज डिवाइडेड बाय देयर रिस्पेक्टिव स्टैंडर्ड डेविएशंस. सो correlation between 10x and y is equal to the covariance between 10x and y divided by their respective standard deviations. इसकी standard deviation है, ये उसकी standard deviation है. Okay? So variance of 10x is 100 times the variance of x, which is equal to the covariance of, तो ये 10 जो है ये 10 square होके फिर square root से आके ये कट जाएगा. So this would be equal to x divided by square root of variance of x, y divided by square root of variance of y, which is equal to rho xy. So 10x और y के बीच में जो correlation है is the same as the correlation between x and y, and this makes sense. Why? Because x and 10x, there is no new information there. Knowing x, I know 10x. Knowing 10x, I know x. So जो information मुझे 10x और y के बीच में मिल रही है वही मुझे y और x के बीच में भी मिलनी चाहिए, वही y और x के बीच में मिलनी चाहिए. ठीक है. Similarly, I can show that, you know, if minus 3x और y के बीच में, this would be equal to minus rho of x and y. ये भी शो कर सकते हैं, ये भी शो किया जा सकता है. नाउ आई एम गोइंग टू स्विच वेरिएंस ऑफ सम्स को दोबारा करते हैं, वेरिएंस ऑफ सम्स, but this time of correlated random variables, of correlated random variables, variance of sum of correlated random variables. recall के recall for independent x and y, variance of x plus y was equal to variance of x plus variance of y. ये इंडिपेंडेंट के लिए, ये सिर्फ इंडिपेंडेंट के लिए था, ठीक है. अनकोरिलेटेड के लिए भी ये चलेगा, but if they are dependent or correlated, then what would be the variance of x and y added together? Variance of x plus y would be equal to, let's try to follow the definition. Let's try to follow the definition. So x plus y is a random variable. So this would be equal to expected value of variance of x plus y should be equal to the expected value of that random variable minus expected value of that random variable, whole squared. So this is the variance of sums when x and y may not be independent, So I'm trying to find that out. So this would be equal to expected value of x minus expected value of x plus y minus expected value of y whole squared. Okay. So this would be equal to expected value of x minus expected value of x whole square plus y minus expected value of y whole square plus 2 x minus ex y minus ey. Very nice. So expectation is linear. If it is linear, I can compute the expectation of first term, the second term, and the third term. Recognize that the first term is simply the variance of x. The second term is simply the variance of y. Okay? So this is the variance of x plus y. अगर ये इंडिपेंडेंट होते तो ये यहीं पे काम खत्म हो जाता. Why? Because ये जो third term है, this is the expectation of this third term is giving you the covariance between x and y, और वो covariance जो है वो zero हो जाती. लेकिन since it is not zero, so this would be equal to 2 times covariance between x and y. Covariance between x and y. Okay. But remember हमने रो एक्स वाई को डिफाइन किया था एज कोवेरियंस ऑफ एक्स एंड वाई डिवाइडेड बाय सिग्मा एक्स सिग्मा वाई. ये हमने ऊपर रो को डिफाइन किया था ऐसे. रो वाज डिफाइंड एज दिस गाय और दिस गाय, एक ही बात है. कोवेरियंस ऑफ एक्स वाई डिवाइडेड बाय सिग्मा एक्स सिग्मा वाई. So I can write this as variance of x plus y is equal to variance of x plus variance of y plus 2 times rho between x and y sigma x sigma y. So अगर आपने वेरिएंस कैलकुलेट करनी है, sum of x plus y की वेरिएंस कैलकुलेट करनी है, so that's the sum of the variances plus this additional term here, Okay? If rho is zero, it will implies that x plus y की जो variance है is equal to variance of x plus variance of y. And x and y are said to be uncorrelated. Okay? Second case, if the correlation is greater than 0, then variance of x plus y would be greater than variance of x plus variance of y. उससे बड़ी होगी क्योंकि ये तीसरी वाली टर्म जो है ये पॉजिटिव होगी. ठीक है. And third, if rho is less than 0, then variance of x plus y, sum की जो variance है, is going to be less than the variance of x plus the variance of y. उनकी वेरिएंसेस के सम से कम हो जाएगी क्योंकि x और y एक दूसरे के इफेक्ट को कैंसिल कर देंगे. x और y एक दूसरे के इफेक्ट को कैंसिल कर देंगे. Okay. Now we can show that, or your proof again is in the notes. We can show that the correlation इसकी maximum value जो है वो +1 है और minimum value -1 है. There is a very easy way to prove this. Variance is always greater than 0. Considering that, you can easily prove this. Yeah, please take a look at this. Okay. So rho is equal to 0 means, by the way, ये मैं खाली rho इसको लिख रहा हूँ, but it's really the correlation between two random variables. So it should be written as rho xy is equal to 0 will imply that x and y are uncorrelated. That does not mean that they are independent, but if they are independent, then they will be uncorrelated. So not necessarily independent. But if they are independent, then they will definitely be uncorrelated. Okay. So if rho xy is equal to 1, +1 or -1, then this tells you a linear relationship between x and y. X and y are linearly related. If the correlation takes extreme value. What is the maximum correlation you can get between two guys? The magnitude of that +1 or -1. Okay, +1 का मतलब है कि अगर x increase हो रहा है तो y increase हो रहा है with the same extent. Okay, so correlation is a measure of knowing one random variable given the other random variable. अगर मैं आपको एक random variable बता दूं, and if the correlation is high, then you can easily guess the other random variable. Okay, which is the basis of machine learning. Machine learning के अंदर अगर correlation ना हो, if the correlation is 0, जो मर्जी कर लें, you cannot predict the other random variable. There is no way you can predict the other. बस random guess कर सकते हैं, predict नहीं कर सकते उसको. But if there is some correlation between x and y, then knowing x you can predict y, or knowing y you can predict x. Okay, so the maximum value that the correlation ka magnitude can take is +1. That means there is a linear relationship between x and y. Okay, and you can prove that. So I'm going to do one example here. Okay, so let's say that x, y, z are independent normal 0, 1 random variables. Let me define u is equal to y and v is equal to z. Okay, so how many people think that u and v are independent? Are they independent? Yes or no? Are u and v independent? Anyone? So u and v are independent. Because u is equal to y, v is equal to z. और हमने पहले ही बता दिया कि y और z जो है वो independent normal 0, 1 है. Okay. So u and v are going to be independent. Okay. So what would be the correlation between u and v? It would be 0. Now I'm going to change something. And that something is कि मैं u के अंदर जो है एक x ऐड कर देता हूं और v के अंदर भी एक x ऐड कर देता हूं. ठीक है. Now what I have done is कि there is this random variable x, part of which is contributing to u का part जो है वो x है. इसी तरह v का part भी x है. ठीक है. There is this z guy of course in v, y guy in u. So if there was no x, then u and v would have been independent and uncorrelated. Okay. But if there is a common factor between these two, which means that now there is a good chance that knowing u I may be able to guess V, or knowing V, I may be able to guess the other guy. Okay. So now what is the intuitive answer to this? Intuitive answer to this कि रो कितना होना चाहिए? What would be your intuitive answer? देखें, x की और y की कंट्रीब्यूशन इक्वल है u के अंदर, x की और z की कंट्रीब्यूशन इक्वल है v के अंदर, तो जो कॉमन फैक्टर है बिटवीन u एंड v, जो कॉमन फैक्टर है वो x है, जो अनकॉमन फैक्टर है y और z में कुछ कॉमन नहीं है, बिकॉज दे आर कंप्लीटली इंडिपेंडेंट. ओके, y और z में कुछ कॉमन नहीं है. सो तकरीबन क्या आधा जो है वो इंडिपेंडेंट फैक्टर से आ रहा है और आधा जो है वो डिपेंडेंट फैक्टर से आ रहा है. सो आई मे एक्सपेक्ट के इनकी जो रो है, the correlation between x and y, this is probably 1/2. ये guess किया मैंने, ऐसे ही तुक्का लगाया है, but it's an educated guess, it's an intuitive kind of a guess, and we will see that this is actually the answer. This is actually the answer. I can easily calculate that. कैसे? कि covariance between u and v by definition is equal to the expected value of u minus eu multiplied by v minus ev. Okay, which is equal to, what is e of u? Expected value of u. Expected value of x be 0, expected value of y be 0 है, expected value of z be 0 है. Why? Because they are all normal 0 1s. Okay, they are all normal 0 1s. So इसलिए इनकी expected value 0 है. So expected value of u भी 0 होगी, expected value of v भी 0 हो जाएगी. So this would be simply u and v. Okay, so this would be equal to expected value of x plus y and x plus z. Okay, this would be equal to expected value of x square plus expected value of xy plus expected value of yz plus expected value of xz. Okay, now each of these three guys, x और z और y, ये तीनों इंडिपेंडेंट हैं, तो ये एक्सपेक्टेशन जो है ये ऐसे अलग हो जाएगी. एक्सपेक्टेड वैल्यू ऑफ x, एक्सपेक्टेड वैल्यू ऑफ y, each of those is 0. So ये भी 0 हो जाएगा, ये भी 0 हो जाएगा और ये भी 0 हो जाएगा, and you will end up getting expected value of x square, which is equal to the variance of x square plus the expected value of x का whole square. Okay, which is equal to variance of x, okay, plus expected value of x का whole square. Remember, variance का formula expected value of x square minus expected value of x whole square. So this would be it. And expected value of x is 0 and the variance is 1. So this is 1. This is 1. Now variance of u would be equal to variance of x plus y. X and y are independent. X and y are independent. So this would really be equal to variance of x plus variance of y, which is equal to 1 plus 1. Normal 0 1 है. So this would be equal to 2. So similarly, variance of v would also be equal to 2. ये सारा क्यों हमने मालूम किया? Because I wanted to find out the correlation between u and v, which is equal to covariance between these two guys, between u and v, divided by sigma u, sigma v. Okay? Which is equal to the covariance between u and v. We calculated that to be equal to 1, and sigma u is square root of the variance of u, which is square root of 2 into square root of 2, which is equal to 1/2. This is what we had expected. What we had expected. So I'm going to now delve into a very interesting, very useful topic. It's called conditional expectation. We have done this in some way. जब हमने conditional distributions की थी, so conditional expectations came up at that time. Okay, so remember, for discrete case, continuous case, दोनों के लिए की थी. I can write it for the discrete case, for the continuous case, f of x given y, x given y. This was given by f of xy joint divided by the marginal. Joint divided by the marginal. Okay. So this is the conditional PDF, conditional PDF of x given y is equal to y. तो ये किसका कंडीशनल पीडीएफ है? एक्स का कंडीशनल पीडीएफ है, ठीक है. सो दैट मींस आई कैन कैलकुलेट द कंडीशनल एक्सपेक्टेड वैल्यू ऑफ एक्स, कंडीशनल ऑन वाई इज इक्वल टू वाई. ओके, सो जस्ट लाइक एक्स की एक्सपेक्टेड वैल्यू फाइंड आउट कर सकते हैं. रिकॉल कि एक्सपेक्टेड वैल्यू ऑफ एक्स क्या थी हमारे पास? एक्सपेक्टेड वैल्यू ऑफ एक्स थी इंटीग्रल ओवर ऑल एक्स, एक्स मल्टीप्लाइड बाय इट्स डेंसिटी फंक्शन. ओके, so what would be the conditional expected value of x given y is equal to y? This would also be equal to integrated over x, because this is expectation of x. Okay, integrated over all x, x multiplied by the density function. But now the density function has to be conditional density function, which is f of x given y dx. Okay. This is how you would find the conditional expected value. Okay, और discrete case के अंदर expected value of x given y is equal to small y would equal to, instead of integration, you will have summation upon all values of x multiplied by p, x given y. This is called the conditional expectation. Okay. So I'm going to give one example here. So this example is very interesting. So let's say we have two random variables, PMF joint PMF of x and y is given below. And that is, let's say कि यहाँ पे हमारे y की वैल्यू है 0, 1, 2, और यहाँ पे हमारे पास ये x की वैल्यूज हैं 0, 1, 2, 3, 4, 5. Okay. So let's say these values are 0, 0.05, and 0.2, and then 0, 0.05, and 0.2, and 0.1, 0.1, and 0.1, and 0. Let's say 0, 0.05, 0, and 0.1, 0.05, and 0. ये नीचे वाले थोड़े खराब हो गए, कोई बात नहीं, इसको 1, 2, 3, 4, 5 ऐसे कर लेते हैं. So ये ऐसे. Okay. So now what is the probability that y takes the value 2? What is the probability y takes the value 2? Py of y. Probability y takes the value 2 is you add up all these guys together. This is equal to summation of this guy, which is equal to 0.1. Okay, so this is probability y takes the value 2. Okay, so फिर इन सबको ऐड करें. 0.4 would be py of 1, and 0.5 py of 0. You can see that this is a probability mass function, because इन तीनों को ऐड करें तो आपके पास 1 आ जाएगा. इन सबको भी ऐड करें अगर तो 1 आता है आपके पास joint PMF को. Okay. Now I'm interested in finding expected value of x given y is equal to 0. Expected value of x given y is equal to 0. Need to find. I'm interested in this. Okay. For this, in order to find this, I need to find expected value of x given y is equal to y. वो find out करने के लिए आपको ये conditional density, conditional probability mass function आपको चाहिए x का. Okay. And how do you find that? So p x given y is equal to 0 is equal to p x y, x and y is equal to 0 divided by py of 0. Yeah. So probability mass function of x given y is equal to 0 ये हम निकाल सकते हैं। इसको निकालने के लिए PMF of x given y is equal to 0. X is 0, 1, 2, 3, 4, and 5. Okay, so y is equal to 0. Okay? If y is equal to 0, so this would be equal to pxy 0, 0, which is this guy, divided by the sum. So this would be 0.2 divided by 0.5. 0.2 divided by 0.5. How do I get this guy? I get this guy because p of x given y 0 given 0 is equal to pxy 0 and 0 divided by py of 0, which is equal to 0.2 divided by 0.5. So this is equal to 0.4. So I'm going to write 0.4 here. जरा आसानी हो जाएगी. 0.4. This is also going to be 0.4. Okay, and this is going to be 0.2, and then these guys will be 0. These guys will be 0. This is PMF of x given y is equal to 0. इसी तरह एक हम PMF निकाल सकते हैं given y is equal to 1, given y is equal to 2, वो सब निकाल सकते हैं, लेकिन हमारा उसमें इंटरेस्ट नहीं है. Why? Because I am only interested in expected value of x given y is equal to 0. So what would be the expected value of x given y is equal to 0? Expected value of x given y is equal to 0. What would be that? कैसे निकालेंगे? So this is your PMF. This is your PMF. Okay. So x takes the value 0 with this probability, conditionally 1 with this probability, conditionally this value with this probability. So expected value of x, ये मैं यहाँ पे लिख देता हूँ. इसको थोड़ा ऊपर मूव करते हैं. Okay. So I can write that expected value of x given y is equal to 0 is 0 times 0.4 plus 1 times 0.4 plus 2 times 0.2, which is equal to 0.8. ये कैसे आएंगे कि these are the values, ये वो जो 0 और 1 और 2, these are the values that x takes, and these are the probabilities. ये जो green में आ रही हैं, these are the probabilities or conditional probabilities with which x takes these values. Okay. Oops. So, this is how the conditional expectation is defined. So, very interesting result that we will cover in the next class. So, next class जो है वो on Tuesday. That would be. We have 3 more classes after this one, so we will finish the conditional expectation and then conditional variance in the next week, and then we will have 1 more class, and that in that last class. Either we will do some revision, कुछ में भी एक तो additional topics हैं वो हम cover कर लेंगे, which I will not make you responsible for the final, but we will cover those anyways. So we will see. If there is any question, 3 ही लोग हैं यहाँ पे, Saleh, Abdullah and Wael. Thank you very much for staying. बाकी लोग तो छोड़ गए हैं हमें. So any question आप तीनों में से किसी का?
नहीं sir.
Great, thank you. Saleh, Abdullah.
No sir, no question.
ठीक है, great.
No sir, thank you.
Great, thank you very much. I'm going to close the session now, and I will see you guys on Tuesday. Thank you.